Hello guys, I'm Hitesh Tripathi, and since we have already talked about internet computer why and what is NNS wallet, so from this video I'm gonna talk about development. Or don't worry, in this video, pretty much in the end we'll do some coding as well and deploy our first dApp in internet computer. And there are many more things as well, like what are canisters, cycles, controllers, principles, many things. Okay, so let's just start with the video, and uh, everything will be self-explanatory. Some things can be hard to understand, but this is what is blockchain development. Blockchain development is supposed to be tough, right? So let's just start with the video. So first thing, to start development, you need to have TFX SDK installed in your machine. Okay, we have already talked about what is DFX SDK and how to install it in our previous videos. Also, I have given, enough information about internet computer blockchain. So if you haven't watched these two videos, just go and watch them as well, because that will be because I mean that will be too much easy for you to first do the base and then start the development. That's why I'm telling you to just go and watch those two videos as well. So, right, we were talking about DFX SDK. I hope you have already installed DFX SDK. If you haven't, just open your terminal. Okay, right in your browser, create first app in IC. Pretty much you will get the first link of Internet Computer org, and if you will scroll down, you will get the URL to install the SDK as well. So just go to your terminal, put it there, press enter. After the command is done, you can simply write DFX version and you will get the version of DFX SDK installed in your machine. Don't worry, I'm not going to give you a go through of this article, so I'll just close it and I'll go to terminal. So you see here I have already installed DFX in my machine and it is 13.0, and the latest one is 14.0, but that doesn't matter. You can install the latest one as well. Okay, and that doesn't matter at all. So I'll just close this terminal here, and we'll start with some terminology. Okay, which will be like too much important to start with the development. So first thing we are gonna talk about is canisters. I have already talked about them as well, but I'll again try to define them. So canisters are basic building blocks of internet computer blockchain. Okay, everything whichever is hosted in internet computer decentralized cloud is inside canisters. So a smallest unit where all the code is deployed, where all the calculations are done. You interact with canisters only, okay, via different types of endpoints. So everything is pretty much revolving around canisters. So via entire development, you will be talking about these canisters. That's why I'm telling you the first term in overall terminology, what are canisters. So I hope it is clear. You can simply take it as a block where you are deploying your code, where your all functions will get run, where your memory will get stored, where your calculations will get done, and with which you will interact, and everything will be done inside a canister. Okay, a canister can hold up to 4 GB of heap memory till now. Okay, you can take it in simple words, 4 GB of memory till now. Okay, now inside canisters, there can be two types of endpoints. Okay, what are endpoints? API which we will use to interact with internet computer blockchain, right? So inside canisters, we are going to code two types of endpoints, that is query calls and update calls. Suppose you stored some memory, you stored some code inside a canister. Now, obviously, you will have to interact with that canister or blockchain to get some data or to upload some data, right? For that, you will need to have some endpoints with which you will interact to the server. or decentralized cloud, that is internet computer blockchain. So there are two types of endpoints, that is in general query calls and update calls. Okay, now update calls are simply, as the name defines, to update some data to the blockchain, and query calls are to get some data, to serve some data from the blockchain, right? So we have two different types of calls. Now there can be millions of canisters inside blockchain, right? So how are you going to identify each canister uniquely, right? Up till now, I remember if you open Internet Computer Dashboard, so up till now there are already 3 lakh canisters, if I'm not wrong. Okay, for metrics and okay, so there are already 3 lakh canisters over Internet Computer blockchain, right? So how are you going to check with which canister you want to interact with, right? So for that, every canister has a unique identifier. We call it a principal ID. Okay, so every canister have a unique identifier, that is a principal, and it looks like something like this. Okay, so this is a test canister I made for you guys so that I can explain you the development or deployment over IC. So every canister has this kind of unique identifier. We call it a canister principal. Okay, or canister ID. You can also say it canister ID. Now, these are canisters. Okay, so somehow, let's just say we deployed some code over canister. Okay, and we need to control who can uh, interact with some endpoints. I mean, let's just say I deployed some confidential function over canister. Okay, we can also call it a smart contract, but smart contracts usually exist over other blockchains, so we call it a canister here. So there is some confidential endpoint, and I want to put some access control over that endpoint. I mean, I don't want everybody can come to my canister URL and invoke that endpoint and simply get the result. I want some specific users only to call, to be able to call that URL or canister endpoint. How will I do that? So for that, to be able to do that, to put access controls over endpoints, or to revoke access, or to provide access to some specific users, I need to be able to I mean differentiate uniquely between different users, right? I mean, there are two users between A and B, and I need to be able to differentiate between these two users. I mean, blockchain canister, who has the endpoint, need to be able to differentiate between these two canisters. How will canister do that? So every user, whoever interacts with Internet Computer Blockchain canister, have a unique principal ID as well. Okay, so in the same way, the canister has. So usually only two things interact with Internet Computer Blockchain. Either a canister. How? Suppose there are two canisters, canister A and canister B. A canister can call other canister as well. So in this way, we are calling that a canister is actually interacting with the blockchain, right? A canister A is interacting with canister B, means canister A is actually interacting with the blockchain. Second way can be when a user actually interacting with the blockchain. I mean, I am a particular user and I connected with internet identity, or I'm doing the development and I am interacting with some canister and calling some endpoint. In that case, I am the caller of the endpoint, right? I'm the caller of the endpoint and I am interacting with the blockchain. So in these two both cases, there will be a unique identifier principal associated with the caller. Okay, in case of canisters it will look like this, and in case of users it will look like something same, and that will be of 64 words or 64 bits. Okay, so this is what known as principal ID. Okay, so every user or every caller, whoever calls or interacts with internet computer blockchain, has a unique identifier. We call it a principal ID. Now this is what when we want to control some endpoints or put access control over some endpoints. Now, There can be a second case as well when we want to control the deployment of a canister, right? Like who is responsible for deploying code to a canister? I made a canister using NNS wallet, and now I want to define who will be responsible to deploy the code, right? So a particular canister has some controllers as well who will be able to deploy the code in the canister, who will be able to add some more controllers or to that canister or remove some controllers. So particularly complete canister will be controlled by those controllers, and those controllers are none other than some principal IDs. And when I say principal IDs, they can be some other canister or some users as well. So a canister particularly can have controllers, and those controllers can be some other canister or some particular user, and those users will get identified using principal. Okay, fine. So I have already told you what are canisters. I have already told you different types of endpoints inside a canister. We'll be talking about different types of endpoints more in further videos, but I gave you an introduction in brief so that development will not become too much complex for you. Now, uh, then I have already told you about controllers and principles. Now let's talk about cycles. What are cycles? Basically, you nothing in this world is for free, right? And blockchain also costs money. Okay, so to interact with canisters, not exactly to interact with canisters, but basically to host some data in the blockchain. We are deploying our code in the blockchain. We are doing calculations over blockchain. We are deploying, we are storing, I mean, we are using blockchain as a decentralized cloud. So we have to pay something. I mean, okay, so basically, canisters also need some kind of fuel to get running in the blockchain, and that fuel is known as cycles. Okay, so cycles are basically the fuel which canister uses to persist its state to do calculations inside continuously inside the blockchain. In case your canister get out of cycle, your canister will get freezed, and any user or any other canister will not be able to interact with that canister over blockchain. Okay, you can when your canister get freeze. So in that case, that doesn't matter. That doesn't mean that your canister is get deleted and you won't be able to interact with it again. Simply you can fuel up or top up your canister again, and you will be able to interact with it easily. Okay, so these are cycles. It's same as gas fees in Ethereum, but I have already told you that it's reverse gas fees. So here, the person who is developing over internet computer has to pay the fees. Okay, who is the controller of canisters has to pay the fees. Fine. Now, so I have talked about different things. Now I'll be talking about in development particularly. Terminology is over, basic terminology, not development. So basically, there can be two types of development environment in internet computer. One can be your local development, and second can be development directly over blockchain. So if you are rich, you can do development directly over blockchain. Otherwise, you can also develop over local environment as well. So let's start with the development. I'll simply go open my terminal. Since I already have dfx installed, I'll simply write dfx new. I'll name the project test. Okay, so dfx new to initiate a new project, and test is the name of my project. I'll press enter, and now it will make a template folder structure inside my machine. Okay, so let it just complete. Also, one more thing. What I'm saying is making a 20 to 30-minute video is I mean very rough, and no user is interested to watch this much long video. So instead of this, what we can do, we can have live sessions over weekends that can be of from 30 to 1 hour, and where you can ask your doubts in the live session itself. So if you guys are interested in that as well, You can ask me in comment section and I will think about that and inform you guys about those live sessions as well. You can take them as Motoko Bootcamp or IC Development Bootcamp. So I already have the folder template initiated. I'll simply cd into it and write code dot, which will simply open VS Code inside that folder. I'll open a terminal. Okay. I hope you will be able to, let me just zoom it more. Now it must be visible to you guys. Okay. Now it must be visible to you guys. Here's the template folder for a DFX project or internet computer project. Inside source folder, we have two folders, test backend, test frontend. Basically, we are not going to talk much about frontend in this video, so I'll just ignore it for now. But as I've already told in previous videos, that you can host frontend as well over internet computer blockchain. So that can be React project, that can be Angular, that can be any static framework, Docusaurus, Next.js, Hujo, everything. Okay, everything or anything. Now, then there's normal gitignore file, then there's the fx.json inside which every configuration of canister as well as environments, env files. So this file is very important. This is basically DFX uses SDK uses this file for all the configs related to canisters and deployment environment. Then there is package.json basically, and then there is webpack.config.js. We'll talk about this file more when we'll be learning about front-end development over internet computer blockchain. But for now, let's just ignore this file as well. Now let's just go to dfx.json back. Inside this, you will see there is a configuration canisters. Okay, inside which you will have two canisters, basically test backend and test frontend. Since we are not talking much about front end for now, we'll remove this configuration and there is only one canister, that is test backend. That is a backend canister inside which we have two configs, main, which will define the main file of the canister, and what is the type of canister? It is a Motoko canister. We can have two types of canisters, that is Rust or Motoko. We are going to develop everything in this channel over Motoko since I am not familiar with Rust. So this will be constant in whole development videos. Okay, then these are some complex configs. We'll talk more about these configs when we will be doing complex development, like adding different networks and different environments. Okay, now let's go on the canister main file. Since it's a Motoko canister.mo is the file extension for Motoko, then we are writing a canister code. Any code, any endpoint we want to deploy inside a canister, we are going to write it inside actor structure. You can say inside actor and parenthesis, whatever you say it inside actor. So basically, an actor keyword before parenthesis defines that this is the code of a canister. Okay, so we can also name a canister. So I'll name it as test, inside which I simply defined, or the template has a function, that is a query function. You can simply see a public keyword so that anyone will be able to call this endpoint. Then query. Okay, so query simply tells us that this endpoint is actually a query endpoint. Okay, if I remove simply this from here, then this become a update call. Okay, so in all update calls, if you write query, it become query call. So right now it's a update call. Its name greet, arguments getting passed name as text. Okay, we'll talk more about data types in Motoko in further videos, but for now I am only telling you the deployment. Then any public endpoint inside a canister will be async await, since you have to wait for the blockchain response. Okay, then return type as text. Inside parentheses, you will write As the return type is text, I'll simply write a return statement which is returning the text. Since I already removed the query keyword, so this endpoint is a update call. I'll write a query call as well for you guys. Public query function. Let's just say test, and it will simply return a int to you guys. Okay, fine. Now we have two endpoints. One is query endpoint and one is update call, or query call and update call. Okay, so basically, what's the difference? Let's just talk about the difference as well in this video. Query calls are basically to serve the data from the blockchain or to get the data from the blockchain. Since this does not require any type of check, okay, so query calls does not undergo blockchain consensus. That's why query calls return response very fast. One thing, okay, you can't update any data over the blockchain using query calls. Second point, now update calls. Since update calls are generally used to update some data in the blockchain, this requires a check. I mean, who is uploading the data, and that update is not a fishy. That's why update calls need to go through the blockchain consensus. And that's why update calls take some time to get finalized. That's why update calls can take up to 2 to 3 seconds and more than that, based on the number of calculations which you are doing inside a update call. And query calls takes less than 1 second or a half second. I mean, these are pretty fast. So you need to make sure whenever there is a requirement of an update call, only in that case you are using update calls. In all other cases, you can use a query keyword and make them a query call. Okay. Now, suppose I want to deploy this canister locally. What I will simply do, I will write dfx start background, and it will simply, okay, dfx is already running. Because I may have run that command previous as well. So if you want to stop it, dfx stop, it will simply stop the dfx, and then to rerun it, you will simply write dfx start again. I don't think it will super soon stop it. It will take some time. So let's just work with same dfx environment only. Okay. So you can simply write dfx start background, and okay, for now let's just clear it. After running dfx start background, you simply need to write dfx deploy your canister name, that is text backend. It will start deploying the canister in your local environment. You can simply see writing, I mean, console of the command, and in the end you got some url. So basically it's a url to the candid ui in the local environment. Candid UI is a very useful thing. Let me just tell you about this as well. So Candid UI is basically to test your endpoints. Like you have Postman in Web 2, you can compare it to Candid UI. You can simply pass the arguments and call it, and you will get the result. Till now, there is no way that you can put some access control over endpoints. So whatever endpoints you are going to test, that must need not have any access control. Okay, and this is query endpoint. Like you can simply check also that this is query endpoint and this is update endpoint. Now if I will simply query, it return the result in 0.012 seconds. If I'll simply put this, update call will take some time, 2 seconds. Okay, so this is what I have already told you. Update calls take some time because of consensus. Now we were talking about local deployment till now. Now we are talking about deployment to the IC blockchain. How can we do that? To do that, first thing you need to do is add canister ID of a IC deployed canister. Okay. For that, what you can simply do, add a file and name it as canister ids.json. Inside this file, you will be giving the configurations for IC canisters. So For now, you can simply check the syntax what I am writing. My canister name was test backend. Inside it, I will write simply IC and my canister ID. I have already made you a IC canister, so I will just go and paste it here. Now, to deploy this canister to the IC, there is very simple command dfx deploy. I will specify the network, that is IC. Okay. Then, since I haven't configured any wallet till now, I'll simply write no wallet. We'll talk about wallet configuration and dfx wallet in some other video. For now, you just check this command, and then I will write simply my canister name. I'll run the command, and it must deploy the canister. Sometimes, since my canister already has some endpoints installed, so when I will deploy it again and remove those endpoints from there, it will ask me that do I really want to proceed and remove those previous endpoints. In that case, uh, it's a kind of warning, you can say, okay, where it is warning you that whether by mistake you are removing those endpoints. So I just simply wrote yes, and it deployed my canister to the IC. Now this is the canister candid UI to my IC deployed canister. Okay, so this time I'll be getting response directly from the blockchain. I'll simply write Hitesh YouTube and will do call, and I'll get the response from the blockchain, and it took 3 seconds. Update call. If I'll call a query call, it took simply 0.237 seconds. So this was pretty much it. I mean, I have told you enough about internet computer blockchain and deployment over blockchain, right? And we'll be talking more about development and deployment over IC in my further videos. Till then, if you haven't subscribed this YouTube channel, subscribe this YouTube channel, share this video to your friends. If you have any doubt regarding anything, regarding development or anything, you can ask me in comment section, and think more about those live sessions. If you are interested, tell me in comment section. I will interact with you more, and we'll plan something out for live sessions as well. Thank you guys for watching this video.